So it's taken us a while to get here, but we finally get to the fundamental theorem of algebra, which states that every polynomial equation with degree greater than 0 has at least one root in the set of complex numbers. The number of generated solutions will equal the degree of the equation. So recall that the degree of the equation is the highest exponent in the polynomial equation. So that degree is going to tell you how many solutions that you're going to get generated. So if it is a degree of 2, you should expect to get 2 solutions. A degree of 3, you should expect to get 3 solutions, and so on. Now, sometimes those solutions repeat themselves, as you'll see here in the first example. Many times those solutions do not repeat themselves. So the way we can solve a polynomial equation is any number of ways, one way being factoring them. So we've learned all sorts of different ways to factor, and they could come into play during this section. So example 1 says solve each equation, state the number and types of roots. Remember what a root is. A root is a solution. So when you solve for x, you're finding the roots. So on example 1, part A, here at the top, x squared plus 6x plus 9 equal to 0. This can be solved by factoring. Since we are trying to factor it, and since it has an exponent of 2, we do like it set equal to 0. So we're going to go right to factoring into a binomial pair, because we can split up x squared as x and x. And factors of 9 that add up to 6. What are two numbers that multiply to be 9 but add to be 6? Well, that would be 3 and another 3. 3 times 3 is 9. But the insides is 3x, and the outsides is also 3x, and that does add up to equal 6x. So then we would set each set of parentheses equal to 0. So you have x plus 3 equal to 0, and another x plus 3 equal to 0. And when you solve both of those, they're both going to generate the same solution of x equals negative 3. But remember what I said, that even though we're going to get 2 generated solutions, sometimes the solutions repeat themselves. So the number of solutions we have and the types of roots, these are real solutions. They are not imaginary because they don't involve negative square roots or the imaginary unit I. So these are real solutions. And we did generate 2 real solutions. However, it is only one unique real solution. Unique meaning not repeating. Part B, x cubed plus 25x equal to 0. So this one is ready to be factored. So how would we factor this one? And notice that both the first and the second terms both contain an x. That means that I should start this one out by factoring by distributive property and by factoring out an x. So when I factor an x out, x times what is x to the third power? Well, that would be x squared. And x times what is 25x? Well, that would be 25. Then we would set each part equal to 0, including what we factored out. So we would set x equal to 0, and then we would set x squared plus 25 equal to 0. And x equals 0 is already solved for x, so that's actually one of the solutions. To solve x squared plus 25 equal to 0, we would subtract 25 from both sides. So that would give us x squared equal to negative 25. And since it's x squared equals negative 25, and we're supposed to be solving for x, we should do a square root of both sides, because remember, square rooting cancels out an x squared. So that leaves you with x equals, and remember, since we just square rooted both sides of the equation, we need to use plus or minus. So what is the square root of negative 25? Well, it is a square root of a negative number, so it will have an I with it. And the square root of positive 25 is 5, so that would be plus or minus 5i. So that falls in line with what we would expect from the number of solutions, because with a degree of 3, we should expect to get 3 solutions. So, but what are the types of solutions or the types of roots that we got? So we got one real root, because 0 is a real number. But then we got 2 imaginary Or we could say another word for imaginary is complex roots, because positive 5i and negative 5i are both imaginary, or we could call them complex roots. 1a is actually quite similar to the one we just did. So is this one ready to be factored? And yes, it is, because it is set equal to 0. And again, since both terms contain an x, we can factor out an x by distributive property. And that leaves you with x squared plus 2. We would set both of those equal to 0, so x equals 0 and x squared plus 2 equal to 0. This is one of the solutions already, because it's already solved for. And for the other one, we should subtract 2 from both sides. So that would give us x squared equals negative 2. And then we can do a square root. Square rooting will cancel out being squared. So x will equal, and we have the square root of negative 2, which again will involve an I because it's the square root of a negative number. However, you can't take the square root of 2. There is no whole number that will give you the answer to the square root of 2. So I will leave that inside a radical sign. And since we did square root both sides, I should use plus or minus. So we have plus or minus I square root of 2 as our other solutions. So the number of solutions we have 3 solutions. We have one real solution, or one real root. And then since we have plus or minus I squared root of 2, that means we have 2 complex or imaginary roots as well. Let's do one more in this section. So x to the 4th power minus 16 equals 0. This one is ready to be factored. So how do we factor x squared minus, or x to the 4th power minus 16? Well, we can split up the x to the 4th power as x squared and x squared. We can split that up equally. And then what are some numbers that multiply to be negative 16 but add up to be the middle term, which is 0, because there is no middle term? That would be positive 4 and negative 4, because inside terms would be 4x squared, outside terms would be negative 4x squared, and that does add up to be 0. So we do have it factored correctly. We can now set each part equal to 0. And to solve the one on the left side, I would subtract 4. So I'd have x squared equals negative 4, and then square root both sides. And that would give me x equals, since square rooting cancels out being squared, if I square root of both sides, I should use plus or minus. And the square root of negative 4 is 2i, because the square root of 4 is 2, but it is the square root of negative 4, which means that I have to have an I. On the one on the right side, I would add 4 to both sides. So that would be x squared equals 4, and then square root both sides of that. And I'm square rooting a positive 4 this time. I still need to use plus or minus, but the square root of positive 4 is just 2, so that would be plus or minus 2. So we have 4 solutions. We have 2 of them are complex because they involve I, or imaginary unit I. And then we have 2 solutions that are real, because positive 2 is a real number, and so is negative 2. And so 2 complex solutions and 2 real solutions means that we have 4 total solutions. Again, we should expect to have gotten 4 total solutions, because as you see up here, we have a power of 4, and the power will equal the number of solutions generated.